Welcome to Sairam Triple YouTube channel. Let us discuss. Continuation of module 1 on the from the previous video. Collision cross sections. It's the area contact between two particles during the collision. So it's a collision between two particles. So collision will occurs in the two in between two, right? So for example, if suppose if you are fighting with your friends, so it's a collision between two persons, right? So like that. Here also two particles. It is also the total area of impact for simultaneously occurring processes such as ionization, excitation, charge transfer, chemical reactions, etc. The effective cross section is obtained by simple addition, that is Q total is equal to Qi plus Qc plus Qe. Ionization, excitation, and charge transfer. The mean free path. The mean free path is defined as the average distance between the collision. Okay, depending upon the internal energy of the colliding electrons, the distance between the two collisions vary with the mean free path. The average of this is mean free path. Right. The mean free path lambda is equal to k by p in cm. So centimeter, where k is the constant, rho is the gas pressure, and microns. Okay. Next, ionization process. Gas is a so ionization process will occurs in the if the media is gas, right? So gas is involves everything, movement of ions or movement of required particulars. Our state almost perfect insulator. So gas is a perfect insulator, everybody knows. However, when the high voltage is applied between the two electrodes immersed in a gaseous media, the gas becomes conductor and the electron breakdown occurs. So for example, I'll tell you, if suppose that there is a gas present and if suppose two conductors are near to each other, if you pass electricity, what happens? It will conduct, right? For example, there is a high voltage area, or if suppose any grounding fault will be there. So what happens if you go near to that point? What happens? Conduction will occurs, right? So conduction occurs in the sense that is so it reaches the it won't break down. So ionization process, the process that they are primarily responsible for the breakdown of gases are ionization by collision, photoionization, and secondary ionization, right? So ionization by collision, collision in the sense collision between two ions. The process of liberating an electrons from a gas molecules with the simultaneous production of positive ions is called the ionization. Okay. In the process of ionization by collision of free electrons collides with the neutral molecules and gives rise to new electrons, positive ions. Ionization by collision, the electric field is applied across the two plane parallel electrodes, shown figure in the next slide. And electrons starting at the cathode will be accelerated more and more between the collision with other gases molecules during the travel towards the anode. So as you can see the diagram here, there is high voltage is applied from the anode to cathode. The electrons, ultraviolet rays will be there. So cathode to anode, so there is a movement of electrons must be there. So what happens? This is the distance. Current limiting resistor is present because of to limit the current. So to limit the current here, and so adjustable HV source, high voltage source, the cathode, and this is anode. Ultraviolet light must be there because of two energizing purpose. Okay. Ionization by collision, the energy is gained during this travel between the collision exceed the ionization potential Vi, which is the energy required to dislodge electrons from its atomic shell. Then ionization take place. So ionization by collision, this process can be represented as E electrons plus E. Epsilon is greater than Vi, and E electrons plus A plus E electrons, right? E negative. Where A is an atom, A plus is a positive ion, and E negative is the electron. Photoionization, the phenomena associated with the ionization by radiation. Photoionization involves the interaction of radiation with the matters. So photoionization occurs when the amount of radiation energy absorbed by an atom or molecules exceeds its ionization. Photoionization, just as an excited atom emits radiation, when the electrons returns to the lower state, to the ground state, the reverse process takes place when an atom absorbs radiation, right? So photoionization occurs when lambda is less than or equal to C H by V. So Hc by Va. H is the Planck constant, C is the velocity of light, lambda is the wavelength of the incident radiation, Va is the ionization energy of the atom. So Townsend current growth equation. So as you can see the diagram over here, there is a supply voltage over here, VB, or the supply battery or whatever. So here there is ultraviolet rays for energizing purpose, and there is a cathode to anode. So there is a recombination take place, and then even though inside there is a diffusion occurs, right? So current limiting resistor, it would be controlling the flow of electrons. So that's why we have here current limiting resistors, okay, and adjustable HV source, high voltage or high voltage sources. It's adjustable, supply like auto transformer or whatever you consider, okay. Like supply is adjustable, high voltage source. So if suppose once the ultraviolet hits into this part, what happens? The ionization take place, and then there is a moment of recombination will take place. Thousands current equation, referring figure, let us assume that N0 is electrons are emitted from the cathode. When one electron collides with the neutral particles, positive ions and electrons are formed. This is called ionization by collision. Okay. Thousands equation, current equation, let alpha be the average number of ionization. Collision made by an electrons per centimeter travels direct direction of the field. Alpha depends upon the pressure, rho and EIP. So and is called as the thousands first ionization coefficient. If any at any instant distance x from the cathode, let the number of electrons be nx. Okay. So Thorne current growth equation, again continuation, when the nx is electrons travels further distance, dx is given is the distance, okay. When x equal to 0, nx equal to n naught, dnx by n, just differentiating because variable is there. So alpha nx, nx is equal to n naught exponential of alpha x. The number of electrons reaching anode x of d, so nd is equal to n naught into exponential of alpha d. So finally exponential of alpha d minus 1 is equal to nd minus n naught by n naught. So I is equal to n naught into exponential of alpha d.